Hey, here we go. A little bit more hydrocarbon stuff. Today we're going to look at fractional distillation. So this worksheet involves doing a little bit of cutting out. Okay, so we've got fraction names, we've got fractions with approximate ranges, and we've got typical uses. Lovely, fantastic. However, what we are going to do today is we are obviously not going to cut them out for reasons. Let's just say that, for reasons. What we are going to do is we are just going to fill it in with the information that we have. Okay, so we have to put these in order. So which ones do we have? We have gases. Gases are obviously, let's just write this, gases are at the top. Okay, gases are at the top. What other, I'm going to zoom out a bit so I can get them all in there. There we go. Gases are at the top. Okay, so let's use those. We then have petrol next. Petrol is next. Okay, petrol is next. We then have kerosene. We have kerosene. We have diesel. Diesel. And then we have fuel oil. Okay, and then finally at the bottom we have bitumen. Okay, now what on earth are these things used for? Well, this one is used for, I tell you what, I'll just label it one. This one is this one, domestic heating and cooking. Okay, now petrol, number 2, that's a terrible 2, is obviously fuel for cars. Okay, kerosene, 3, is fuel for aircraft. Okay, are these actually in order? These are actually in order, which is mental. I guess you're not meant to notice until you cut them out. But there we go, they're actually in order. So 4, 5, 6. So they're actually in order on the sheet. So you can just number them. Okay, we're just going to number them. Excuse me. Right, so we now have some properties. We'll worry about those. We'll worry about those later. Now next it says crude oil fractions have different uses. Complete the fractions. So what did we just learn? We just learned that gases are to do with domestic heating and cooking. Petrol is fuel for cars. Kerosene is fuel for aircraft. Diesel is fuel for trains. Fuel oil is fuel for power stations, and bitumen is for that. Right, it says, state one other use of the fraction used for fuel for trains. Well, cars. Specifically fuel for, don't just say cars. Okay, what do you mean cars? Are the seats made out of it? You know. Fuel for power stations. What do we think? Large things use it. Transport ships. Those big container carrying transport ships use this. Okay, it says during fractional distillation of crude oil, petrovapors condense higher up the fraction column than kerosene vapors do. Describe the changes of state that happen during condensation. Well, nice and easy. It's gas to liquid. Now, which one has the lower boiling point? Well, it's petrol, because it condenses higher in the column. Higher in the column. Which has the smallest hydrocarbon molecules? Petrol. Because the further up you go, the smaller they get. It travels further up the column. Up the column. Ignites more easily. Again, petrol. Okay, it ignites more easily because ease of ignition increases as you go up. Increases as you go up. Has the higher viscosity. Well, that one's kerosene. Okay, because the lower down, the longer chains, viscosity decreases as you go up the column. Okay, so lower downs are more viscous or less runny. Okay, lower down, equals more viscous. Right. Explain how crude oil is separated into simpler, more useful mixtures by fractional distillation. Just include the essential processes. Right. Well, first of all, you have to vaporize the crude oil. First of all, you have to vaporize the crude oil. Okay. They rise up. They rise up the fractioning column where they cool. Okay. They will eventually condense. Different fractions condense in different places. Fractions condense in different places. Okay, that's the answer to that. There we are. That's me talking about fractional distillation a little bit. And I've just had a message which I'll read out just to add some fun to the end of the lesson. What happens if you nuke a nuke? There's a large explosion. There we go. Thank you very much for watching, everyone. Enjoy.